All right, so this is my response into Matt Anderson's uh, talk about Kepler's laws. He states the first law as being orbits are elliptical with the sun at one focus. And so this is talking about how orbits of the planets around the sun um, are in an elliptical state because they are not perfectly circular. Earth is pretty close, but it's not quite there. His second law was equal areas at equal times. And so this is explains that in that elliptical form, the closer we get to the sun, you take like a large portion of that, and then that area has to be equal to how long it takes on the other side in an equal amount of area, which if it was like super like oblonged, you could have like an area like that big that could probably on one side closer to the sun that could probably measure up to like the same as like this wide on the other side, and it would take just as much time through the small area on the orbit path as it would through the big area. His third law is simply can be simply explained as t squared, which is the period, is proportionate to a cubed, which is the oh shoot the semi-major axis of the orbit. And so using all these, it's hard to um, it's difficult to send probes that far out because one, it takes a lot of time. It's going to use a lot of fuel, and I did a little bit more reading into it, and I mean, I had a question. It's like, okay, why are we sending them outwards and maybe not like up or down? And I was simply met with it requires even more fuel because to send them outward on the ecliptical plane of the sun, um, it's easier because with the mass and like the rotation of the sun, it's just likewise easier to send them outward that way. Whereas if you go perpendicular up or down to the ecliptic plane of our sun, it takes about approximately 20 kilometers per second more to get out of the gravitational pull of our Earth. So it makes more sense to send them outwards. So these formulas that Kepler came up with in this third law kind of sort of help derive distances between our planets and their velocities. So that way, it's easier to plan when to send out um, space probes on a path that's going to take them by the planets in our solar system, so that way they can use those to gain more speed and send them farther at a faster rate. The last time they did this, I mean, I may not be totally right, but I was just reading through some stuff on the internet about this. But since the Voyager 1 and 2, the planets won't realign in the same way that those were for like another 175 or 76 years. So it's, I guess in a sense, it's just difficult because you have to like, I guess, wait and time sending a probe out along with like the planets and how they line up just to make it even like slightly easier. Probably makes it 10 to 15 times easier getting a probe out there farther. So we've recorded plenty of like planets and like objects past Neptune. So I mean, we already have like something out there, but To get it outside of the solar system like soon, just probably isn't like a very likely state, just because of all the planning that would need to go into it and how long it would take to actually like get outside, like travel that like amount of distance to get out of our solar system. Yeah.